Hey guys, I'm Devansh Mangal from DesignVerse, and this is a brand new lecture on design of machine elements. So, in the last lecture, we discussed about the basic requirements of the machine elements, right? We discussed the general purpose and the special purpose types of machine elements. We also discussed about the objectives of the machine elements, right? The strength, rigidity, and all those things which a machine element should possess. Okay, and at last we discussed about the design methodology. Okay, in this lecture we're gonna focus and give more emphasis upon the design of a sync machine element. Okay, so I'll just clear that off. Okay, cool. So in this lecture, let's first start with the design of machine elements. Okay, so we already discussed like why the need for designing is and all those things. Okay, so thus like it's I've written it like very like up to the point that to ensure the basic design requirements we need to design the machine elements. Okay, and for that the calculation forms the basis. Okay, so why is it so? Okay, as I already told you in previous lectures also that mathematics like maths is the basic tool. Okay, I could also say that he's the best friend of an engineer. Okay, you know why? Because mathematics helps in a situation where nothing else can help you. Okay, it can give you a mathematical formulation and justification to your design. Okay, so for giving justification to your design, you require to do some calculations, and calculations are done on the basis of mathematics. Okay, so like here there's like just a representation is given. Okay, so first of all we like this is a stepwise and only specify the functions of elements. After that we determine the forces and like suitable material, then determine the failure mode, then determine geometrical dimensions. Okay, generally people do this like the starting only, but it's like the fifth step in the design procedure. Okay, after that we modify the design of the assembly and manufacture it. Okay, and lastly we like make the drawing so that it can be manufactured in like entire globe. Okay, there's no need or dependency on a particular this thing. Okay, so let's first start with the step number one. So what actually is step number one? So the specification of the function of machine element, right? So what does this mean? This lecture might be a bit long, but like this forms the basis of the entire machine design series. Okay, on the product design, whatever you would say. Okay, I've already cleared that up in the previous lectures also. So and I'll just say stick to the word machine design. Okay, okay, so so this lecture is very much important. Okay, so I'll request you guys to pay more attention. Okay, so first step is specification of the function of machine element. Okay, so first of all, let's say I have a rotating disc. Okay, let's say a rotating shaft. Okay, and I want to support it. I need to support it. Okay, or contain its motion. Okay, how am I going to do that? Right, the question is how. So I have a bearing with me, a machine element known as bearing. I can use a bearing, and with help of that like a bearing can with the inner race mounted like this, and the outer race can be mounted on some other like uh, a piece where like it will hold the shaft. Okay, the bearing casing perhaps, and in that way the motion of the rotating shaft is contained. Next in line we have like the key. Like there are so many other elements. I have just given a few examples here. So key helps us in transmitting the motion. Let's say I have to transfer motion from this shaft to, let's say, another shaft. Okay, so I have gears. Okay, both the shafts have gears mounted on that, but the gears, how am I going to mount the gears onto a shaft, right? So that is possible with the help of a key. You all might know the key is, right? If you don't know, like, you can comment in the section and I can make a video on that. After that we have a spring. So spring is a generic element, right? It can either be used to store energy, for example in clocks, or it can either be used for like measuring the force. How? Well, in spring balance we use as a principle. You all might have listened to the formula F equal to kx and all those things, right? Where k is a spring constant. Sorry. Okay, so you all like the first step is like to specify the machine elements. Okay, um, the function is very necessary, because on basis of that only we are gonna design that. First we need to know, right, what we actually have to design. After that we draw the FBD. You all might already know what an FBD is. FBD is free body diagram. Well, a professor of mine like give a very simple like definition for this, which is free the body, draw the diagram. Like how is that possible? Well, it's very easy. Let's say, like, I have given a very much pictorial representation here. Let's say there is a, let's take this example. Okay, so what is it? There is a wedge kind of thing. There's a block resting on it. Okay, so I need to make this FBD of this block. So I'll just free the block. Let's say take the block, take the block apart from the wedge. Okay, and like now the block is free, right? uh, as we all know, the weight of the block will be acting downwards, right? Normal reaction will always be perpendicular, and the direction of motion is like that, so maybe the friction will act like this. Not the direction is like this. Okay, maybe a force is acting here. Okay, so this is like just the basic FBD of the block. I'm not going into much details here, but you all like already know, so let's stick on to that. So more emphasis should be given upon what forces do we need to consider. So actually there are two kind of forces. First one is external, and second one is internal, right? External forces are those forces which you can see, like you can like it's present, right? For example, in this arrangement itself, you can see like there is a force acting onto this block, maybe an external force. It may be perhaps because of some energy source, or maybe some power source, right? For example, this guy is like pulling up the block. Okay, so those things are there, so this will be considered as an external force. Here you can see, right? While pushing the blocks, the friction is acting here, the weight is downwards, and the pull force is like this, right? And the pull force on this string will be like this, and the weight of the block is like this, normal reaction is like this. So all those things are there, right? So let's first start, like let's first talk about like what are the forces to consider in. So the first force to consider is the useful load. It's very first thing, because let's say I have to move this block, so I have to pull it, so this is an useful load, right? Next one is static force. So what is the static force? It's because of the dead weight of the machine elements, right? What is dead weight? The weight of the machine which is like in its normal operating condition. Okay, next thing is the frictional forces. Frictional forces, we often forget to add frictional forces, but those are very much necessary. Okay, after that, centrifugal forces. Let's say something is like like some there is a car perhaps. Okay, the car is turning around the corner, so centrifugal force will be acting on it. Okay, and like just to make tell you that this particular lecture series, right, it can help you with your external competitions also, maybe Supra, Baha, F cycle, and all those things. Okay, so do focus on to these things, because this designing thing is helpful throughout the your career. Okay, next thing is thermal gradient. So what actually thermal gradient means is that and at some distance, let's say there is a heating source, perhaps there is a heating source, and because of that this particular part is heated, and there is a thermal gradient in it. Okay, maybe this must be the hottest tip of the rod, and this must be the coldest tip. In between them there is a thermal gradient, and because of thermal gradient there is a force. So there are equations governing that, and those equations should be considered. Okay, next thing is residual stresses. Okay, residual stresses are the stresses which are there in the machine part, because of the like after maybe a particular this manufacturing things. Okay, let's say I welded a part. Okay, so welding this two joints. Okay, like there is a welding joint here, so this causes a residual stress onto this particular joint. Okay, so those things should be considered. There are few like already standard formulations for that, so you can like involve that in the designing process. Stress concentration due to abrupt change in cross section area. Well, this is perhaps the most important thing, and as a design engineer we always forget this thing. Okay, so one must consider this. Okay, So and also like there are two things. First one is like we assume that assumptions are all has to be taken, otherwise you cannot design a particular thing, right? So we assume that the whole load is concentrated on a single point. Okay, maybe the person is pulling up this rod. Okay, so perhaps maybe there is some other kind of arrangement also here, but uh, then also like it's very difficult to concentrate the load. Okay, so like to calculate the load, so thus we specify the whole load on a single point only, or maybe we distribute it evenly across the whole cross section. Okay, now let's move on to like this is the step number 2, and that solves it. Okay, now moving on to the step number 3, which is selection of material. So we already have like the machine element which is required according to the specified function. We already know the forces involved. Now it's time to decide the material of the component, right? So how do we decide the material? So these are the four criterias. Okay, four basic criterias, which involves the availability, the cost, the mechanical properties, and manufacturing cost. Okay, manufacturing considerations. Okay, so how's that? Availability means the material is available nearby only. So in that way, it's very easy for manufacturing person, like whosoever gonna manufacture it. It will be very easy for them. Next thing is cost. Why cost is very important? Because like if you know like you all have a budget before designing, right? So if you don't want to exceed that budget, the cost plays a very important role. Okay, when mechanical properties are also very much important, because at the end of the day your design should be robust enough to survive the entire life cycle. Okay, next thing is manufacturing considerations. So manufacturing considerations are to be done in order to like to make the component easy to manufacture. Okay, so these are the few steps, few things we consider by selecting the material. So let's take an example. Let's say I have to make an engine block. Okay, and let's say I have to make this kind of railing. Okay, the beautiful railing. So what material am I gonna choose? I'll choose cast iron without any ado. You know why? Because casting can make complicated shapes, right? And that complicated shapes, this is a very complicated shape, right? And if I'm gonna like just stick onto this like by manufacturing it, maybe by another method, so it will be very much costly, and perhaps like it will be very difficult also. But the cast iron can be used for casting process, and casting can produce complicated shapes. Thus I used cast iron for doing this. So I chose cast iron because of the manufacturability is very much easy. Next thing is the crankshaft. Okay, so crankshaft is made up of nickel chromium steel. So why is that? Because of nickel chromium steel has a high fatigue strength. The crankshaft is subjected to a fatigue load, right? So for that I need something which can survive that part. So I chose nickel chromium steel. So thus you can see the mechanical properties of nickel chromium steels help us in choosing crankshaft material to be nickel chromium steel. Okay, next thing is transmission shaft. The transmission shaft like uses the plain carbon steel. You know why? Because it is available as in a rod form. Okay, the transmission shaft is manufactured within the rod only. Okay, a rod is there, so only plain carbon steel is present in a rod like structure, even after its high strength. Okay, because anything which has a high strength, it's very difficult to make rod or some elements out of it. Okay, but plain carbon steels are available in this rod form. So that's why I choose plain carbon steel for transmission shaft. So we also saw the availability part. Okay, the next thing is car body structure. So it's made up of low carbon steel. There are two things why I chose this. First one is cost. It's very easily like available, and also the manufacturing things which I'm gonna use it here. So the property of the low carbon steel is it can easily be cold formed. Okay, we're gonna discuss the more on this, like what cold formality is, and casting and other manufacturing process in another lecture series. Okay, but for now you can like just have an example, and like you can just know like what all how a design engineer thinks. Okay, So this lecture series will help you with that, so that you can like start, doing your own designing. Okay. Okay, I guess like the step number 3 is clear. Now what we have already chosen the this material. Okay, sorry, machine element which is required. Next, we already know the forces onto that machine element. Now we selected the material also. So let's move on to the next this step, which is the failure criteria.